Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can before the end of today's webinar. And finally, at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. All right, with that, we will go ahead and kick off today's webinar, which is Securing Kubernetes Applications with HashiCorp Vault. Our speaker today is Sheriff Jackson, Nick Jackson. I just saw your Twitter handle. That's pretty awesome. He's the developer advocate at HashiCorp. Nick, thanks so much for joining me today. Really appreciate it.
It's an absolute pleasure. I'm looking forward to it, and I'm really looking forward to showing you all fine folks, hopefully some good stuff.
Awesome. Well, I'm going to put myself on mute, take myself off camera, and let you get right to it then.
Awesome. So what are we going to look at today? Well, we're going to look at how you can secure Kubernetes applications with HashiCorp Vault. And you're probably thinking, well, okay, I'm guessing you hear you because you realize that the need, but I think you kind of got to look at, like, what are the areas of secret data that you need? So fundamentally, Kubernetes does a great job, right? And the key thing is, though, that Kubernetes is going to do a great job around things like static secrets. But when you start to look at the composition of a typical application, so what are the kinds of secret data that a typical app that would use? And we've got a little example which I've coded up and I'll share with you all. But I think you end up with these basic 4 categories. So I'm going to have things like static secrets, API keys, simple things like that I need to be able to provide to my app. Database credentials. Most applications are going to need to access a data store of one form, whether that's a sort of a Postgres database, a Redis queue, or a Redis cache, or anything, any form of sort of data store. You pretty much, a lot of applications need that as a capability. And you need to secure the inputs to your application. So whether it's an absolute front-facing application, which is open to the internet, or whether it's internal to your application, but you want to be using encryption in transit. So you want to secure the endpoints of your application with X509 TLS certificates, right? And quite often you have to deal with personally identifiable data. And sort of personally identifiable data comes in a number of different forms. It could be things like usernames and passwords. Could be things like user details, my address, or something like that. It could be things like my credit card number. I might want to actually store passwords, and I might want to, but all of that type of data, you want to store it encrypted at rest. And there's a kind of a number of different ways, but like breaking that down, when you think about it, well, providing static secrets, relatively straightforward, but there is a kind of a bit of workflow around it, right? And then database credentials. I think this is kind of one of the difficult things, because in an ideal world, what you want is a database credential, which is unique to the specific instance of an application. Now, you go find me a DBA who will create you unique database credentials for every pod that you're running in your Kubernetes cluster. And I'll make sure that we hire them, because I don't think that person exists, right? It's a difficult thing to do. It's very time consuming. But you want to be able to do that because you want to be able to run short-lived credentials. You want to be able to tie a specific instance back to your your audit logs. And then that sort of securing applications, we kind of talked about that. Sort of the encryption in transit is not easy. I mean, running your own certificate authority, generating certificates, providing them to the application, securing them to make sure that people can't just generate them ad hoc. That's not an easy thing to do. And the personal data, Well, there's a number of different ways. You can use things like bcrypt, scrypt. A lot of application programming sort of SDKs have got that sort of capability built in. But more often than not, you want to do more than that. If you want to encrypt something like my address, personally identifiable data, or something, then you end up with a larger blob of data. So how do you do that? Well, I can use symmetrical keys. I can use PKI to kind of encrypt small bits of data, and I can generate keys, and I can encrypt keys with PKI, which encrypts data, right? It's not that straightforward. And ideally, you want to be able to separate reads and writes as well. There's a lot of things coming into play. From a developer's perspective, I don't want to write encryption. I don't want to do it because it's not my specialty. And more often than not, I don't want to make a mistake doing it. So all of these things we can help with Vault. So Vault is kind of as an application, it's a server. And you're going to run it inside of Kubernetes. And I'm not going to kind of go into how to run Vault on Kubernetes today because we've got a number of different guides. I want to kind of show you its use more so than running it, because running it is kind of as simple as just running a Helm chart. And I'll put all of these links and we'll get them all sent out to you. But what you kind of want to start to do is you need to start thinking about the separation, right? And Vault does that. Because Vault, when you think about it as an application, you've got to think about it, and I think it's kind of like in 3 core areas. So you have authentication. So authentication is something which gives you access to Vault. And then you have secrets. So secrets are things which are stored in Vault. So things like those keys, PKI certificates is a kind of a secret. Encryption and transit, we kind of regard those as secrets. And then you have policy. So what policy does is it ties authentication to a secret. So I can say that this application or this user has access to these secrets through policy. And policy is a pretty straightforward looking thing. It looks like this. And we'll dig into this in a little bit. But you can have these textual documents. I can define secrets. I can define capabilities on those secrets, so I can separate responsibility, read and write, and things like that. And I specify those, and I can tie those to a user. But we're dealing with applications. So how do we do that? Because what we actually have is Kubernetes. So one of the kind of the core problems that you're going to have is kind of dealing with this. You need to trust a pod to have access to secrets. How do you do that? Well, the way you do that is that you configure Vault to use and to be able to understand things like Kubernetes service accounts. Kubernetes service account is a cryptographically verifiable thing. Well, the token linked to a service account. So I can actually use a service account to tie things to Vault. And this is what it's going to kind of look like. So we deploy a pod with a service account token. We use the service account token to authenticate against Vault. Vault gives us a Vault token. We can then use that Vault token to access secrets inside of a Vault. But the beauty of this is that we don't really have to do a great deal, because all we're going to be doing is looking at these Kubernetes annotations. Okay, so let's dig in. So first things first, just a quick recap. So when you're kind of dealing with secrets, you'll find that maybe this is a sort of a typical sort of approach you would use with Kubernetes. Now, I'm not saying you would define your secret like this in a YAML file, but all the secrets are going in the cluster somehow, but it's just defining a secret. So I have a secret inside of Kubernetes called payment API key, and that has a value. Now, in order to access that secret, typically what I'm going to find myself doing is I'm going to be using environment variables. So I'm either going to be sort of injecting those secrets into environment variables and using that kind of 12-factor approach for reading my app. And one of the complexities, though, is that, well, what if you want to use structured configuration files? It doesn't lend itself easily to be able to do that. And the thing is as well that a static secret really only considers static things like API keys, right? I mean, you can do things with TLS certificates, but then you've got to use like Let's Encrypt, or you've got to use cert generator. Ideally, what we really want to be able to do is a consistent workflow. With Vault, we can do that. So with Vault, we transfer this approach into this. So I can define through Kubernetes annotation, secrets, and configuration files. And that's all I need to put. I'm using the integration to be able to do that. I'm going to show you how to do that now. Right. So what I have, and I've already got this running, but I've got a Kubernetes cluster, and I'm running this in just K3s, but you could run it, anywhere. It's just Kubernetes. And I'm going to share, as I say, this demo with you. So you can see here that I've currently got 3 pods running. I have my Vault -0, and that's my Vault server. So my Vault server is going to be running. It's running as a stateful set, so I obviously need to be able to store the data and things. I have my Vault agent injector. What is the Vault agent injector? Well, it's a mutating controller. So when I submit a pod to Kubernetes, the agent injector will mutate it based on the annotations that I just showed you there. And it will do things like generate configuration files, which I can then read. And I've just got a database going here, and it's just a standard Postgres database, and I've just got this running for convenience. But there's really nothing special going on with that. You can see the config file there. Right. So what we want to do is we want to kind of replace that static secrets approach. That's the first thing we're going to do. We want to be able to inject secrets into our pod. So in order to do that, I need a number of different things. I need to be able to authenticate to Vault, and I'm going to do that using the Kubernetes service account. So inside of my pod, my application specification, I'm defining a service account, just calling it web, and I have the auto mount token specified. So I'm just going to put that into the deployment. And then here inside of my deployment, you can see that in my spec, I'm just referencing that service account name. So this pod, when I deploy it, with this deployment, when I deploy this deployment, yeah, you know what I mean? That's going to automatically inject that service account token, which I can read. Now, Vault, the agent injector, is going to read that service account token automatically, and it's going to call the Vault API. It calls the Vault API. Vault will validate that it's correct and that that service account is allowed to log in, and it will return a token. So we set that up like this. So what we need to do is go through a few steps. So the first thing that we need to do with everything inside of Vault is you need to enable things. So not other than the kind of the static secrets and cubbyhole, there's not very many things which are enabled out the box. So we're enabling it. So we want to enable Kubernetes authentication. We do that with this command, Vault auth enable Kubernetes. So that's enabled. Now, whenever you've enabled an authentication endpoint or a secrets endpoint, what you need to do is to then configure it. So the configuration for the Kubernetes endpoint, Kubernetes authentication, needs a number of different things. So the things that it needs is it needs the Kubernetes CA certificate, and it needs that because it's going to call the Kubernetes API, and it wants to trust that it is the right sort of API and it can make a valid TLS call. We're not using insecure or anything like that. It needs to know where the Kubernetes host is going to be. And it also needs to have a JWT. So it needs its own token or service account token, JOT token, in order to be able to access the API. And that token has to have certain API access. Again, you can kind of dig through that when you look at the Getting Started guide for how to install Vault on Kubernetes. But what we're doing here is I'm just going to write some configuration. So Vault write Kubernetes config. That is a kind of a standard approach for configuring an endpoint. In this case, the auth endpoint. And I'm going to do that, and I'm going to get the token reviewer, the JWT, and I'm just going to fish that out of var run secrets Kubernetes service account token. So the standard place that exists on the pod. So what I'm doing here is I'm kind of doing a little bit of a nice sort of workaround where I'm executing this command inside of my Vault pod. So that way I don't need to kind of fish out any of these details and manually inject them. You know, I could, of course, read them from the service accounts or anything like that. The Kubernetes host, well, I can get that again from the environment variable, which exists in the pod, and I'm just getting the API for the SSL. And of course, the cert is also available in the service account CRT. So it's kind of like the standard Kubernetes service account situation. So we have that as a setup. So that means now that we have that configured. So now that we've got that sort of that configuration there, what we need to do is we need to create a role. So what the role does is the role is a link between the service account name and a policy. And we haven't defined the policy yet, but we'll get onto that. There's a little bit of chicken and egg there, but again, look at the command I'm using. So I'm using vault write auth Kubernetes role web. So I am creating a role called web, which is bound to the service account web. So that's the one which is in my deployment. The service account namespace, just I'm running everything in the default namespace, but you can kind of choose this whatever namespace you may be running, and then the policies. So what that means is that when a sort of a deployment authenticates against Vault with the service account name web, it will be granted a Vault token with the policy web, which will give it access to a specific subset of secrets. And we're going to get into that in, well, literally just in the next couple of commands. So we write that. This is kind of a lot of setup stuff. You don't necessarily need to do this for every single instance. You need to configure things like the kind of the Kubernetes API stuff, and you create a role probably per pod or per function. How you kind of cut that is a little bit up to you. But now that we've kind of got that, we can start to look at how we can kind of get things up and running. So then let's step through these annotations. So the annotation, agent inject true. That means we want to inject the Vault agent as a sidecar into our pod. And we want to use the role web. So that was the role that I literally just created in the previous step there. And we want to get this secret information. So let's take a look at the secrets themselves. So what I want to be able to do is I want to be able to access a secret called API key. So to create a secret in Vault, then I can use the most basic kind of features, which is the KV, right? So I can say vault KV put secret. I'm going to call it web. So that's kind of like a document. And what I want to do is I want to create a number of secrets in that. I want to call one of them payment API key. I'm just going to set a random value because it doesn't necessarily matter. And I can specify more than one. I could say, I don't know, username Nick. So that command there, what that is doing is that's writing a secret into Vault. And you need access to write secrets to Vault. I have privilege to do so. Now, if I want to read that secret back, as an administrator, you can use the Vault get secret web. And you can see there that the data has been returned and I've got the key that I put in and the username. But this isn't going to help me for my application. So for my application, what do I need to do? Well, for my application, I need to create the policy. So you remember when we created that authentication for that role, I specified that a policy would exist called web. And the policy has access to all of the secrets it defines. So for example, I created that static secret called web. So I can create policy, which has a path. Everything in Vault is an API path, and I have capabilities. So I'm going to specify a path of secret, data, web. And that will give me access to read that secret that I've just written there. So in Vault, again, I need to set this policy. And you're going to be setting things like policy in all of this configuration. That's kind of an operational concern. You'll run that as a side from your sort of your application development concerns. I've got that file on disk here. So let me just run it. I can do Vault, policy, write, I'm going to call it web, and then the file. So that's written the policy to Vault. So now what we can do is we can actually deploy our pod. So let's take a quick look at this. So again, agent inject annotation. That means that we're going to use the Vault sidecar. We're specifying the role. The role has to match the role that I created when I was setting up things in that first step there. I'm going to specify that I want to use certain secrets. So I want to use secret data web, that static secret that I just created. And I want to be able to use that inside of a configuration file because my application uses JSON-based config. I could use YAML-based or XML-based, whatever, it doesn't matter. Because what I can do is I use this inject template config. So inject template config actually uses, it's console template, Vault template. It's a kind of a language, and I can put a link there, but it allows you to extract data out of Vault and you can inject it into your config. So let's take a look through. So I'm just using standard JSON. So I've got a standard JSON field here called DB connection, just some statically configured stuff. Bind address, again, statically configured. But then I'm using this template feature. So I'm saying with secret data web, then inside of there, I can kind of do the mutation. So I'm setting my field name, API key, and I'm specifying that I want to use the payments API key, and that's on the object data of data. And that will actually write me a JSON formatted configuration file to Vault secrets with the name there, config. So this will get written to Vault secrets config. So we can just write that. So let's run that and get that written to Kubernetes. So just pretty standard CoopCTL. Apply that And we can, well, if I could type, we can see that we've got that running now. So if I kind of look into that, what I can actually do, and let me just run a CoopCTL, but you can kind of get that that data out of there. Bear with me. CoopCTL get pods. What did I save my secret as? Well, it wouldn't be a demo if there wasn't a couple of little blips, but that data will then kind of get extracted out of there. Oops. So when we kind of start to look at static secrets, it allows us to kind of build up our application. We can start building up things like this. We can kind of build up our configuration files. And static secrets is only part of the problem. We need to be looking deeper. So what about things like database secrets? Well, database secrets are kind of a bigger problem, because a database secret, I could just inject a static sort of approach, but it doesn't really work. I want unique credentials for each application. The key thing that I want as well is I actually want credentials which are kind of rotatable. I want things to be able to expire, and the way that Vault does that is it's got a concept of dynamic database credentials. So with a dynamic database credential, Vault actually manages the usernames and passwords to access your database. So when you ask Vault for credentials, Vault actually will talk to your database. It will then go ahead and generate the username and passwords. It will pass it back to your application. It's then going to keep a watch on that, because we're going to specify a TTL. So after the TTL is expired, Vault will then go ahead and regenerate those credentials. So it kind of gives you a completely straightforward and simple approach of kind of going through and just automatically generating the credentials. When you start to look at, again, what does it look like in terms of your Kubernetes configuration? It's pretty much the same. So if you look at the static secrets that I just had, I had this template. When it comes to database credentials, I'm using a very, very similar template. Again, I'm doing that secret templates config, and I've got that sort of block there, which is saying I want to use these credentials, and I can inject the username and password. So let's see how let me show you how you set that up. Okay, so again, the first thing you need to do is you need to enable credentials. So a database has to have the sort of the database secrets engine has to be enabled on it. So what we do with a database is we need to create roles. So if we look at a role, why do we need to create a role? Because what a role is going to do is it lets you define things like a creation statement and a revocation statement for those secrets. So I'm going to create a role here called DB app. The database is going to be products. And then I can define my creation statement. So I'm using Postgres. So this is just standard Postgres SQL for creating a role. And I'm just going to say grant select on all tables. So it's a fairly sort of open statement. You could obviously limit that to whatever you want. Now, with the role, I can inject using these template variables. So I'm going to automatically get a unique name and a unique password. And again, the expiration, that's generated for me as well. And I specify what that expiration is here by using this default TTL. So all of these unique database credentials and passwords that I'm going to set will have a default TTL of an hour and a max TTL of 24 hours. What does that mean? Why are there two? Default TTL, if the credentials are not used. So you've got to renew a set of credentials in Vault. Vault Agent's going to do that automatically for you, but Vault will detect that they're not being used because they're not being renewed. Therefore, it's going to revoke them. You don't want stale credentials kicking around. Max TTL, the maximum duration that those can exist for. So a maximum duration that these credentials can exist inside of Vault here is going to be 24 hours. So when I've kind of got that set up there, the next thing that I want to do is do my configuration. So I'm going to create a role, and I'm also going to do my configuration. So I'm configuring a database called products. You see that was referenced in my previous role there. The type is PostgreSQL database plugin. The allowed roles, well, I'm just saying anything for the moment. I can limit that if I want to kind of create some specific further lockdown. And I give Vault the connection URL. So this is the connection to the database. This is what Vault needs in order to contact their database and generate that username and credentials, password. So I can write that. Now that, that I've kind of written that, what I can actually do is generate some database credentials. So let's just quickly look at how I do that in the CLI before I kind of show you how that's done inside of the application. But I'm going to do Vault read database credentials. And you can see here that Vault has generated me a database credential which has a uniquely generated password and a uniquely generated username. And this will happen every time a pod runs. So this is going to be specific for every pod. Again, think about that policy: authentication, policy, and secrets. So the policy, I am defining here, I'm saying that the secret data web has a capability of read, because I only want my application to be able to read my database. My database credentials DB app only has read. I only want it to be able to read. I don't want it to be able to make any updates or changes to any of the configuration or anything like that. And that sort of approach of just kind of doing that policy right is exactly how we'll do that again. So we're just going to write that policy there. So back over in our pod deployment, we've got that role there again. We've got the agent injection annotation that we're specifying. And again, we're saying we want to use the secret database creds DB app. It's a very familiar pattern that you're kind of going to come across all the time. And then I'm using that ability to generate a configuration file. So I'm going to generate a configuration file, which is going to have a custom DB connection, and it's going to be able to use the host Postgres, a user, and a password. The database name, spotting that, is products. And we're just disabling SSL as well. So let's apply that file. CoopCTL, apply. So we're just doing that deployment there. And we can see that that is just coming up. And we're up and running. Okay. So let's take a look at that configuration file. So what I'm doing there is I'm just doing a CoopCTL exec, and I'm just fetching one of my web deployment instances. and I'm just reading the configuration file that I wrote. See that there, vault secrets config. That's based on config file there, vault secrets config. Convention is the name, and everything is always going to be vault secrets. But what you can see is that my pod has that automatically generated username and password in there. I didn't create that. That's just been automatically set up for me. If I run the same thing, because I've got two instances against the second instance there. So, and if I type things properly, you can see there that you've got a different username and you've got a different password, because they are now unique to those pod instances. So we've just solved the problem of how we do database secrets. For a different application, we can separate between read and write because we can create different roles. It's kind of nice and easy. I admit we're doing a bit whistle stop, but we're kind of we're gonna get through this. So what's next? Well, the next thing that we want to look at, which we kind of said earlier on, is we need to look at TLS. And configuring TLS certificates is not a particularly easy thing to do. So how are we going to configure TLS certificates? Well, again, we're going to use Vault, because Vault has got a secrets engine which allows you to generate X509 certificates, the PKI endpoint. How we can sort of leverage those things, well, it's going to be really easy. We can get Vault to be able to kind of inject those secrets for us. We can get it to inject the TLS certificate and the key, the two things that I need in order to secure my app. Just quickly showing you my app code here. This is a simple Go application that I'm running, but I'm not doing anything really clever here. I'm just reading that configuration file in, and I'm going to use listen and serve TLS. So if you've, as I say, I'll share this code. You can have a dig through all of this sort of stuff. So with Vault, we're going to, again, use that annotation secret. And the secret that I want to use is PKI issue. And the template I'm going to use, so I'm going to generate a file with the data certificate. I want the key. So again, I can use PKI issue and I can generate private key. This will make more sense in just a second. Okay. How do we do this? Everything in Vault, I have to enable that endpoint. So I'm enabling the PKI secrets engine. And I want to tune it. So I can kind of tune it to specify the maximum lease that's available for any of the certificates which are generated. And I'm just going to set this to 8,760 hours. This could be as long or as short as you want. Ideally, you want to kind of keep things as short as possible, but it's about manageability. There's always a trade-off. And then in Vault, there's two different ways of handling PKI. So I can either generate a root certificate, or I can use an intermediary certificate if I've already got my own root and I want to kind of use my existing intermediary to sign. I'm just going to use the quick way of getting Vault to generate an internal root certificate for me. The common name that I'm using, so the TLD on my cert, is going to be shipyard runs. That's the name that I've kind of configured for my demo app. And I'm just specifying the TTL for that. So we run it. So we run that, and it's going to generate the certificate, the issuing CA. It's basically done that chain of trust, and it's just going to spit that out for me. I'm not going to use that at the moment. This is just for reference. One of the other things that I can configure is things like the CRL, so the revocation lists. And Vault can actually act as a distribution for revocation lists and also for the issuing certificates. And we can write that into the configuration so that when we generate certs, that information is also readable from the certificate. It's an optional step, but I'm just going to write that in there. So then what we need to generate is a role. So again, everything, we've got to be thinking about that sort of role. And a role is going to kind of specify the sort of the interactions. So I can define a role here, and I'm just calling it shipyard run. And this is quite an open role. But what I'm doing is I'm saying that for the domain shipyard run, you're allowed to generate all sorts of subdomains, and the maximum TTL that a certificate can be generated for 72 hours. Again, I can configure a role how I want different applications. I might have different roles. It's a kind of a user choice. So we're going to run that. So now that I've run that, Vault can actually generate me a certificate. And just kind of from the CLI, that would just look like this. So I'm going to write to PKI issue shipyard run, so the name of the role that I defined in the previous step. And I want to create a certificate with a common name, web ingress shipyard run. And that will generate me the certificate, the key, and everything that I need to be able to kind of secure my endpoint. And it's kind of going to just put it in the document like that. I can specify different formats for the output. Again, this is just for reference. We're not going to use this. Because what we're doing is we're using those annotations. So Vault is going to generate me a TLS certificate, and it's going to put it into the file Vault secret TLS cert, because it's based on this name here and this template. So we're going to take the secret shipyard run, and we're going to extract the certificate, and we're going to extract the key. Let's run this. Apply -F. It is config. Okay, so this is running. Okay, that's up and running there. Just quickly back to that policy. Everything in Vault needs a policy. So the combination of the policies for everything that I've shown you in the demo so far looks like this. So I have the ability here that I can specify secret data web. That's my static secrets. I have a policy for generating my PKI certificates. So I'm using PKI issue shipyard run. This one's a slightly different capability. I'm using an update. And I've got my database credentials. So when we kind of tie all of this together, that I'm having a brain freeze. That will have secured my endpoint. So now if I just quickly CoopCTL logs. Okay, and we can ignore those error messages because we're not interested in those, but we've got that service running there. So if I do a curl, and I'm going to do curl HTTP first, and it's going to be web.ingress, which is just the kind of the setup I've got running here. And I'm getting an empty reply. So let's just put V on there. Okay, bad request, because I've sent an HTTP request or an HTTP server. So my endpoint is serving HTTPS. That's a good start. Let's change that to HTTPS. So again, we can see there that I'm now curling with HTTPS, and it's connecting. It's doing it valid, but correctly curls saying to me, well, you can't do that because the SSL certificate isn't trusted. So what I need to do is just add the CA. I can quickly just test that with the insecure flag, and you can see it works. But let's look at the CA. So the CA we can actually get from Vault. and it's just going to be available here. So this is the address of my Vault server. V1 is the API endpoint, PKI CA PEM, and I'm going to write that to a file. PEM build to. Let me just quickly. CA.pem, and you can see there is my certificate. So now I've got that certificate. I can actually use it, so I can just do my curl now, but I'm going to do my curl with specifying the CA cert. The way that you would do this in a sort of a production environment is that you would have that certificate. You generate the CA. You're going to deploy it to each and one of your machines, or you're just going to pull it as part of your boot process. But we've successfully secured our pod, and it's all kind of up and running and fairly easy. Last thing, encryption in transit. So we mentioned that the kind of the fourth of our problem is how we manage to do encryption in transit. How do we manage to encrypt personally identifiable data? And we're going to do that because Vault's got a feature called the encryption as the transit secrets engine. It allows you to use Vault as an encryption service. I'll show you quickly how it works. So again, I need to enable it. Everything needs to be done enabled. This is kind of like a one-shot thing. And then what I need to do is I need to generate a key because I want to use a key to generate. So a key I can share across applications. I can have it unique for applications. I can have it a unique per user. There's a number of different ways to kind of do this. But once I've got that, then what I can do is I can write some data to the encryption transit engine, some plain text, and it'll give me back ciphertext, which is encrypted using that key that I just generated. Nobody has access to the key. It's stored safely and securely in Vault. Now, everything in Vault, when it comes to storing it, you need to store it in base64 encoded format. So I'm kind of just storing that, again, using the plain text field here, but I'm just setting it base64. So when I run that, it gives me back this ciphertext. And the ciphertext, I can actually decode, because what I can do is, again, I can use the opposite command, and I can specify Vault write. I can use the decrypt command this time. And you can see there I get back my plain text as base64. So let me just quickly echo that into base64-D. And you can see I got the original value back. Now, of course, I can do all of this again with the API. And from your applications perspective, this is kind of what you want to be thinking about. So from an API perspective, I'm just going to, I'm going to use this. So I'm going to curl. I need to specify the Vault token. And I'm just using the root token for the moment. I'll explain in a little bit. But I'm just calling the API for Vault transit encrypt web with that plain text, base64 encoded, and it gives me back the ciphertext. When you look at the application, though, let's see how the application is handling this. So what I have inside of my application is my handlers. So I'll just quickly take you through the app here. I'm two handlers. I've got a pay handler and I've got a coffee handler. So the coffee handler connects to the database. The pay handler is the thing that does my encryption. So that's how is dealt with this block of code here. So if you're familiar with Go, this is a standard HTTP handler in Go. It's called for payments. So all I'm doing is I'm constructing a new payments request. And this is the object type that Vault's going to expect. So it just wants a JSON object. Sorry, this is the request that I'm pushing in called card number. And then I'm just got a simple response. So I get that request, data in, and then I'm calling encrypt data on the Vault client. So let's take a look at the Vault client, because this is actually where the magic happens. This is the interesting stuff. Now, Vault actually has an SDK. It has a really good SDK. It also has a number of different client libraries which you can leverage. I'm not using the client library or the SDK here because I want to show you what little code you actually need to write in order to interact with Vault from your application code. So my encrypt data function, all that's going to do is make an HTTP post request to this URL. So the URL is just v1 transit encrypt web. So web is the name of my key, and I want to encrypt using the transit secrets engine. I'm going to base64 encode the data. So my credit card number that I get, just base64 encoding that, converting it into JSON, and then I'm going to post it to Vault. I'm specifying the Vault token in a header here, xVault token, and then I'm executing the client. And then I'm going to get that response back. So all of that is doing is very, very sort of straightforward, very straightforward approach. I'm conscious of time, but let me just see if I can run this for you. Right, just to show you this working. So let me just write a Vault token temporarily. And again, for a lot of the examples, I'm just using this root token. This is not what you want to be using in production, but you don't need to worry because the Kubernetes auth is going to manage this for you. Right, so let me run my app. Do I already have it running? Oh, I already have it running. Let me run it. Okay, cool. Localhost 9091 pay with a data payload. Clear this, sorry. Pay. I'm all fingers and thumbs. Card number. Put anything in there for the moment. And then we're running that. So you can see that's worked. So all I've done is taken that card number, I've base64 encoded it, and I've sent it to Vault using that really, really simple bit of code. I mean, if I can do it. So the thing is, we need the Vault token, and literally the last thing I'm going to tell you today is how you get that Vault token. And it's very, very easy. So the Vault token, when you're using the injection, is going to be automatically created for you and it's available. So I can use an additional annotation, agent inject token. And what Vault is going to do is once it's authenticated with the Kubernetes service account and obtained the Vault token, it's going to write it to /vault/secret. Sorry, it's up here. Vault/secret/token. And this is an optional thing. You don't have to expose the Vault token to your application, but if you need it to use, say, transit engine, or you want to do some SDK stuff, you can. And that was a little bit whistle top, and I apologize for running through that a little bit quickly, but we've got some links here for you. I've got an example which I've uploaded to GitHub. You can get that there at github.com, Nicholas Jackson, Vault Dev Patterns, and I'll update this a little bit. But all of the files, all of the application that we've walked through, all of the Kubernetes configuration, all of that is in here for you to kind of browse at your leisure. And we're 5 minutes into time, and I can answer any questions async. Please ping me at Sheriff Jackson. But let's have a look at some questions, I think.
Yeah, we have time for maybe one question because we only have 5 minutes left until the end of the webinar. So why don't we go ahead and just do the first one here, which is, does the Vault server need special cluster permissions, or can I run this also only for one namespace?
Yeah, you could run it for a single namespace or multiple namespaces. That setup is sort of configurable by the sort of the Helm chart and also through the authentication, because you're kind of creating those roles. And I'm getting cramped in my leg, which is terrible timing, right?
Right.
So you can set it up however you like. You also don't need to run Vault on Kubernetes. If you've got an existing Vault server and you're running sort of outside, then you can use the same Helm chart to be able to connect Vault up to your Kubernetes server, but doing it outside. Yeah.
Okay, nifty. Okay, so unfortunately, 4 minutes to the top of the hour. We don't have time for any more questions, but guys, please note that Nick and the folks at HashiCorp are going to be getting a copy of all of the questions. So I'm sure they'll be more than happy to follow up with you offline and get your questions answered.
We'll absolutely do that. We'll answer all these questions and send them
awesome.
out.
All right, great. Wonderful, wonderful. Let's see. So do want to remind the audience real quick that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, which I'm sure a lot of people will want to watch it again, it's so great, you'll have the opportunity to do so. We are going to be sending out an email after today's event that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. I know I did mention at the top of the hour that we'd be doing a drawing for 2 $50 Amazon gift cards, so let's go ahead and do that real quick. Okay, today's winners are Nick G. Congratulations, Nick. And our second one is Conrad S. Conrad with a K. Congratulations, guys. Appreciate you guys sticking around. We'll be following up with you offline via email to get your gift card over to you. So please check your email for that. Nick, thank you for such a great presentation. I really, really enjoyed watching it. Good stuff.
Thank you. I just want to kind of call one thing out, which I just noticed, which I didn't make clear. Somebody was asking, can the ciphers be used stronger than base 64? I was only using base 64 to format my text, because structured text, which has got spaces, speech marks, carriage returns, and things like that, base 64 encoding just makes it easy for storage. Vault does not use base 64. Base 64 is not a cryptographic cipher. We're using, it's configurable, so we can use AES, you can use RSA. A number of different ciphers for actually encrypting the data, but yeah, base 64 is not encrypting. It's literally just for formatting.
All right, great. Well, thanks for that clarification. Yeah, and so again, thanks for such a great presentation. Judging from the number of questions we got in, folks were digging it. So thanks again. Really, really do appreciate it. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody, and please stay safe.
Thanks all for watching. Great to see you all.